Hello, welcome back to the stream. Today we're going to be building a UI based on the Division. It's a Diegetic 3D Holomap. Okay, let's get going. So for this, well, before I get started, I just need to get myself situated because my hair is annoying me. Just get my hair out of the way. Okay, cool. So we do this every morning, Monday through Thursday, and we do UI or gameplay, sometimes games jams, sometimes we do audits of games and sit with developers and co-dev stuff. We do art, tech art, UI. So if you've got a request, put it down in the comments and subscribe. Hit us up with things you'd like to see us create. And today, whoa, apparently my microphone audio is really loud. So I'm just going to turn that down a little bit. Also, I realized my music was really loud, so I'll turn that right down. Okay, let me jump over and around. Okay, so off to a great start. It's Monday. Okay, so this is the UI that we're gonna create today. In the Division, there is a 3D Holomap that has this compass around the outside. It can have elements on this UI as well. So what we want to do for this is I think we actually want a widget that we're able to control, and then we want to render that widget to a 360-degree plane, and we'll use a widget component for that. We've also got these buildings that are represented across our map, so we'll set something up for this. And then if time permits, we'll take a look at this waypoint system, although we might do that in another episode. As similarly with these markers and world space glow sort of identifiers, we might come back to that in another stream depending on where we get to. And you can see some examples made by other developers here and here. So you can find these online. I can't actually remember who made them, but if you type in Division Holomap, you'll see these on Google. Okay, so I'm going to use the original reference here. And so we've got a grid. Let's get ourselves started with a simple sort of grid across the ground. You can just lightly see it here. It's got these dots in the corners and these lines. And then it's got these major grid lines as well. So I'm going to use Photoshop to do that. We'll just make a 512 by 512 Photoshop file. I'm going to make this black. And then we'll just get some power of 2 number here. I mean, it's 512, right? So if we go down by 2 pixels, we'll get a really fine 1 pixel edge, which might be too fine. And this might take a little bit of play, but let's go with, actually, yeah, no, I do want. I was going to do it with HLSL code, but let's just do it the material way. Okay, so then we select the inverse of this and just color this in white. So this is our minor grid lines, and we'll also create some pips on the corners. And this pip will be duplicated on all sides, so we actually want this pip to be quite small. I think that was probably okay, actually. How do I get that back? Okay, we'll do this, and then, oh, sadly I made it as part of the image, so we don't want that. Okay, let's go 8 by 8 here, Control-Shift-N for a new layer. And then just duplicate that to our 4 corners. One thing I want to do as well, actually, is take this outside layer that we created. I think it's this one. Maybe, no, it's the bottom one, right? Turn this into a layer and layer via cut. Size this up. The reason I'm doing this is because now I have this white outline and I can play with the opacity on this, just say 70 or maybe 50. We'll save this out. This is a little bit large actually. It's like for a 512. We'll see. I kind of do want to actually make this 3H less out because it's going to just be a 512 texture that we don't really need. Okay, so let's go to our working files UI stream. Let's just go working in here. New folder, division, T underscore grid dots, grid width dots. We'll call it, this is the high density grid or the highly repeated grid. So we'll call this, we'll just call it grid A. Let's just go with some basic names. And then I want a thicker one for the larger lines. Now when we do this, is that we're actually going to be using it at a different scale. I kind of do want to do that through the material. Let's take a look. As you can see here, we've got these grid lines already. Let's just jump into Unreal and set up our content folders. So in here, I'm going to say episode 05. Let's create a couple of assets here. We have a template somewhere. I've got this template. Let's copy this template over. Jump. This is episode 5. This is episode 5. Episode 5. Let's jump into this map. Oh, it doesn't have the cool colors. Let's jump over back to our first map and grab the colors from the floor here. In fact, let's copy this map instead. It's going to be easier. Let's delete the map that we just made, turn this into episode 5. Okay, so in here, we want to make sure that our world settings game mode is episode 5. And we want to make sure that episode 5 is using our episode 5 character. And then let's save all of this and just double check our blueprints, make sure that we don't have anything lying around that we don't want or need. So we have some input mappings, we have some jump capabilities. Let's take a look in our default input mapping as well. See what we've got. We've got jump, move, look. In here, let's create a new mapping context. Put this IMC episode 05. We'll create a new input action. IA map. Okay. So in here, we're going to create our map action that we just had. We'll use the tab key for this. And here we're just going to add another mapping input context for our episode 5. Create a new graph. Call it Holomap. Holomap. Just print this out on begin play. So we'll just check that that's working. Character, press tab, got this hello. So that's cool. Let's make a blueprint to house our map. So we'll call it BP Holomap. Open this up. Let's add a plane. We'll add this to our character. Okay, so we've got the Holomap here. Let's make sure it's at the bottom of the character. And so now we just need to change the scale. So let's go 3. Big enough for a circle? I think it needs to be maybe 4 or 5. That looks a lot nicer there. Okay, so it's a 5-meter circumference that we'll be playing with. And let's create a material for this. Let's put it in a new folder as well. Holomap. Put it in here. Let's create a new material. M_Holomap grid. So for this, I don't want it to be depth tested. It's going to be let's go masked for stats. I think it needs to be translucent to be not depth tested. So let's go translucent. I don't want this to be depth tested because I don't want it to be clipped by any geometry. I want it to always be visible. So we disable the depth test on here. And then from here, what I'm going to do is actually attempt to use ChatGPT. Create a HLSL custom node script UE5 material where I can control a grid line effect. A grid XY size and thickness of the lines. That should be enough, right? Here's a snippet of an XY grid. And then it saturates it at the end, so it's just 0 to 1. So we'll plug this in here. And you can see we have probably got some variables to define, but it might tell us in here what variables we need. So the type is a float2 texture coordinate. Oh, right. We have a float2 texture coordinate. So what are our inputs? And why is it not telling us what our inputs are? And why can't I see this? Okay, cool. Okay, so the inputs are UV grid size and line thickness. The UV grid size, line thickness. So we'll do this. Our grid size is going to be X size. I'm guessing it's a. Actually, is it a float? Let's find out. It is a float2, and then line thickness is a float. Okay, so X size, Y size. And so let's just go 10 by 10 and append these into here, and then line thickness. We'll just say 0.5. Let's see how this looks. We'll put this into opacity, and then we'll use a const color. Say white, the emissive. And then here we've got modifiers must appear before the type line, float, grid X, grid Y. So the output, I guess, is wrong. Output is just a float. Return type CMOP float here. Modifiers must appear before the type float line min grid. Well, let's at least tell GPT what the error is here and see if it fixes it. Error: modifiers must appear before type float line equals min grid x grid y. We use this, and then this is interesting. 1, 2.1, 0.05, 2. Great. Okay, so we have a grid. This is cool. Let's throw this onto our Holomap. I do want to actually ask GPT. I want the grid size to be in world space. So a value of 1 is 1 meter. This makes it easier for an artist because they're like, I have a grid, it's in world space, but the values that I want to edit are obviously in world space. That make a little bit more sense. Okay, so we do this, we get the world position. World pos is is a new input. So grid size of 1 now. See here, we're getting this. This is for a plane parallel I mean, this plane is facing sideways, so maybe it won't work on here, but it might work on the top. Have a look at it on our plane. We'll create a material instance for this and then apply it here. See, that's not working. It's still facing right. Z is up and in the room. It's like, oh yeah, you're absolutely right. There we go. So now we have this. And we have a Holomap with a grid that is 1 meter aligned. So that's cool. And then we can just play with the thickness of the material instance to give it the appearance that we want. So let's go thickness here, 0.01. Open Holomap. That's pretty cool. Let's create, so we had another material, then we were going to do that with a texture. So let's look at using a texture instead. So we get to look at both. So if we go to working, let's have a look at projects. Nope. UXIF, UI stream, working. Rename this to Holomap. Take this grid. let's actually do it directly in our first material, so we don't need two planes. So here we'll create a texture, and we'll do world-aligned UVs. Texture, I guess. World-aligned texture, texture object, convert this to a texture object. Plug this in here, texture size. Well, that is strange. Well, pause. Let's plug. I want to use this as a mask. But let's just plug this into our opacity for now. So you can see here we have a much better effect. And so it says texture size here, but I want it to be based on, well, we'll see. So we'll say, what if we say world size instead? Obviously, again, I want this to be 1 meter. So if we say 100, that might be a meter. So if we go look in our Holomap again, we should get similar. I mean, you can already see if I use this or this, it is 100. So we have two materials now, and to clean this up, let's go generated grid. And then down here, we'll do texture-based grid. Two different methods for how we can do that. And we'll name this as well. So named reroute. We'll just say texture grid, and we'll named reroute on here. So it's generated grid. So we can get both of these variables now. And we can add them together. And you can think of this as adding white to white will create a value of 2, and adding black to black is 0 adds 0, so it creates nothing. And so what we can do is saturate this to bring it back down to a 0 to 1 range and plug this into our opacity. And that'll actually overlay, so we won't see the small grid because the big grid is quite large, but you can see the small grid on the sides here. So what we'll do is we'll do we do have line thickness, that's fine. XY size. Let's do this every 5 meters, and then just bring this right down. 0.001, 2, 3, 5. So you can see now what I'm creating the effect of is back in our reference. We've got these thick lines here. There's these like major grid lines every 500 meters. And we've got these smaller ones representing a different density, right? So if we jump into our Holomap now, we've got something interesting going on. I'd say they're a little bit too thick, and that's probably actually to do with the defaults. So let's just resave those defaults here. Yeah, right. And now that we have ChatGPT, we can generate, we can even generate. So for anyone watching this in the VOD, someone asked, what wizardry is this that I'm watching? Shaders always leave me feeling like putting my head in a blender. And yeah, my response is, well, now we have ChatGPT, we could actually generate things that we want a little bit easier. And then we're just thinking of it in 0 to 1 space. Black being 0, 1 being white. We're just adding layers together. We're just layering things up, and then using it to like lerp to colors and things like that. I find it once it clicks, right? So we have a pretty cool grid. The last thing to think about here is how it has an opacity. It's just solidly locked off after, well, here it's not, but here and in some of our other references that we picked up, we can see it's got a blend out at the edge here. So we want to create that circle and just end at the circle. edge. And so in order to do that for this and to have it be maybe world aligned, we're going to create a new named reroute node, which is our circle opacity. And we'll start setting this up. So circle opacity. So here what we want to achieve is we could either use a gradient, a radial gradient, or we can use UVs, and we can, if you think of UVs as 0 to 1 left to right and 0 to 1 top to bottom, or vice versa. And in fact, if I break this into, or if I create a mask, you'll be able to see this better. If you think of this as two overlapped, can I open this up? Yeah, so you can see here, we've got 0 to 1 left to right and 0 to 1 top to bottom. And so with this in mind, knowing that this is 0 to 1, we can get the center point of this is 0.5, right? So if we had a distance node and we asked, can I please have just a regular distance? Okay, apparently I cannot. Yep, apparently there is, oh no, it's right there. So if we take the distance of this, and it's 0.5, right? We can do some math to basically say what's the distance from 0.5 to the edge, and then maybe even remap it to make a circle. I'm not going to do it that way. I'm going to do the simpler way for now. So I'm going to use this radial gradient. In fact, what I'll do is let's go back to GPT, and let's try and make another quick custom node. So I want to create a world aligned or a similar world aligned ring with configurable thickness and gradient contrast. Something like that, right? So that if we want, we can actually have it bleed out. Again, yeah, you can do this with a combination of sort of subtracting two of these from each other and configuring all the properties here, because you basically get two circles, and then you can do some contrast and stuff math to do that. But it's quicker and cleaner, possibly, to just generate the code and then set up the variables. So we'll plug this in here, and here we got world position again. So we're going to create our properties. We've got world position, we've got world pos meters, which is this. We've got ring origin. I wish it would tell me the inputs in the comments. We've got ring origin. Ring spacing, distance between rings. That's not really what I wanted. I don't want multiple rings. I just want one ring. And actually, to make it even simpler, so I don't have so many variables, I just want one ring. It's based on the 0.5, 0.5 of the UVs of the material. And the only properties are thickness and contrast for a gradient in the case I may want to a nice blow. towards the center would be 0 opacity outside the ring. This just, it's a pattern recognizing software. So if I just tell it, yeah, UV, that's the one, right? And then now you've shifted those UVs into a space where you can just do a circle. But then I'm going to have to make another circle, and then I'm going to have to minus it, and then I can't do a gradient and other things. So let's try the HLSL. Plus, this is a nice experiment and I guess exploration of how easy is it to use GPT to create this stuff. I'm also going to ask it, please put the inputs as comments at the top of the code. Here's your final V3. Okay, so we've got UV's thickness and contrast, awesome. So UV, nice thing now is we literally just have to copy these. So we've got two floats, ring contrast and ring, ring thickness. And then we've just got, apparently we just have UVs. It still wants to be based on world space though, but I guess it doesn't really matter that much. We know we've got the plane. Just before we get too far in, let's add some categories to these assets. I do want to take a look at the suggested input. So 0.053. 0.05. And then add that to here. Ring. What did I call it? Just call it ring. Ring. Oh, actually, yeah, I did need I did need to mask basically from this, but all we've done now is made a ring. And the ring actually clips. So let's just get the contrast here. 10, 100. Cool. Yeah, we do actually still need to mask on the outside. Let's try the UVs that were mentioned. So multiply by 2, minus 1. Review this node. So we have this, then we can distance from this. Essentially the distance to 0, and that's the part divided by then the whole, which in this case is probably just 1. And then you can cheap contrast this assumedly by like 10. So let's go 0.5 here. 0.2. Yeah, so this isn't actually getting me right to the edge here. There we go. And so now we can use this as our circle mask. Named reroute. And that's circle mask. Hopefully it doesn't cut too much into our ring. So if we multiply this by our mask, and we do need to invert our mask as well. So we just put a 1 minus in here. Circle mask. Put this in. And then just, oh shit. Start previewing this, stop previewing this, there we go. So now we've got our basic grid. Yeah, GPT. Yeah, okay, cool. So we've got our grid done. Cool. So 35 minutes in. A little bit of planning and prep conversation at the beginning, but other than that, we're looking pretty good here. Let's have a look at this in our scene. And so this is exactly what I wanted from this prototype. A flying hover disk that we can stand on that looks like a grid. And it opens up all new realms of possibility for map traversal. So this is pretty cool. It's actually moving, you know, with the world because it's world-based grid. And then from here we need to render our city on here, which I'm going to use PCG to help with that. We do have an issue. I don't really like it rendering over the characters so much. Let's take a look at the reference. Yeah, the character's kind of masked out, right? And even here, the character actually has an outline on this one. And here, he's just like, he's fully visible. So what I need to do now is continue flying on the map. Well, firstly, I need to tell this plane to be not colliding. So let's do that. No collision on that plane, none of this, none of that. Let's just go to effects and just turn off all this. So this is all like distance field lighting and stuff I've seen in projects. You know, if you don't do that, you end up with artifacts in your terrains. Okay, so now I can't even see the ring. It's just underground. So let's, on our third person character, let's just move this up. So we'll just put it here. We'll animate this a little bit later. Why is this not rendering very nicely? It's just difficult to see because we have a grid on the floor, I guess. So what we might want to do quickly is grab this floor material and move it to our episode 5, pop it on the floor, and just lower the visibility of the world grid here. Line color, let's just bring this right down. Cool. And let's mute this a little bit more as well. Just make it black, be easier. Cool. And actually the color of the lines is still quite visible. It does help if you've played with shaders for a bit, and so, you know, this is a little, if you haven't done that, here's a crash course in shaders. It's all UVs and lerps at the end of the day. I'd like to think. This is annoying. Can I not get rid of the grid so much? What if I don't want the grid? It's already set to 0. I can't just color pick the floor because it just makes it blue. Got checker roughness, but we don't have like grid roughness. I guess we could go on the tile scale and just set it to 1000. Oh wow, that really helped. And yeah, now it just looks like this ugly thing. That'll do. Okay, so now we just have our grid. It's way easier to see it. Cool. We can see this little minor grid on the ground as well, which is actually also kind of cool, and we could implement it using what we've learned just now. We could implement a subgrid again. It does look kind of cool. So what should we do next? Should we do... Let's have a look. Should we do the compass around the outside, or should we do the city? Oh, I know there's a couple of people watching, so maybe you guys could... which one do you want? Do you want the compass around the outside, or do you want the city rendering? And then later on we might, if we have time, we could do some world align stuff here. I do still need to fix that. Yeah, you're right. I actually forgot about that. So while you guys are thinking of an answer to that, I'm going to go and fix... yeah, so choose compass or world space mesh stuff while I go fix the custom depth on the shader. So on our character, what we'll do is we'll grab this and we'll render it into the custom depth buffer by clicking on this rendering custom depth. We've got a stencil value of 0. That's fine. we don't need to worry about it because we're not doing any other stencils right now for this, but in the, in a bigger project, you might need to control stencil ID as well. And in our grid, what we can do is create a named reroute for the stencil mask. And we can get our scene texture for our custom depth, I believe it's going to be, which I am currently blind to. We've got custom stencil here, but I don't have custom depth. There it is. So from here we can also get our scene depth. This isn't actually rendering with depth because we're disabling depth testing. Let's just plug this into our opacity for now and see what we're getting in our scene. Do the city. Yeah, I could do the city. Okay. So if I hit play, we need to take a quick Google for this. We could even use Super Google. I have my character rendering to custom depth, and I want to mask the. I want to create a mask for that character. Lucent material. Okay. Oh, apparently he's made a he. Apparently GPT is a he. It's made a HLSL for us again. But the logic is to just test where the scene depth is versus something else. Problem being that we are depth testing this. We might need to turn that disabled depth test off. We more than likely will. But it's using pixel depth, so maybe it's okay. Let's go custom here. Plug this in. Does it not have any inputs? Can I copy this text? I cannot copy the text. Okay, so I need to just type this in. Errors expected for function style. And then we've got undeclared identifiers for pixel depth, custom depth. So we'll add those. Pixel depth. Plug this in. I think it's a float, right? Declared identifier custom depth. Did you mean custom depth? Okay, it did Pascal case on this one. And then also warning implicit indication of vector type is W conversion. Yeah, I don't care about you explaining it to me, really. It's like, I don't need to learn. I just need results. Although it is saying, what's going on here. You likely have something like scene texture lookup is directly use. Custom node doesn't allow function style calls with the scene view. You're probably mixing float 2 UVs with a texture. Okay. Let's see what it does this time. So we've got screen UV. What? Asking for a new input now. Let's have a look into this. You can't right click copy. Not on these, no. Nothing happening here. Green UV. Apparently there's a UV in here. I don't believe it. Scene texture, maybe that's actually a node. Scene texture UV. Scene UV. UV. I don't know what it's on about. Scene texture UV doesn't seem to exist. Mask R. Mask R on what? Sorry. I thought color is just 0 to 1. I suppose maybe it's not. We'll mask it anyway, but we're having a problem with whatever this screen UV is. I don't know what it's looking for here. Screen position, sure. Yeah, sure. Okay, so we'll try UVs then. Alrighty. So I'm glad someone in here with Tech Art Chops is helping me out. Has it seriously changed the variable names? No, it hasn't. Custom depth is already defined. We just want pixel depth. Okay. Right, so okay. So now we no longer are actually looking at custom depth. Are we? Is it just doing it manually? Interesting. Yeah, GPT's having some bloody hallucinations right now, I think. Because if you look, it's saying it's equal to the scene texture lookup. Yeah, I've told it to give me the inputs at the top so that I can define them easily. And yeah, it's obviously just hallucinating here because it's like, we've got scene UVs. It's a screen position. Use the viewport UV node. Cool. Pixel depth. Yep, we got that. Depth to tolerance, a small constant. I mean, we'll add it, but basically it's going to still complain because there's an unidentified scene texture lookup that it never told me as an input. So it's doing that thing where it's like, it's written some code, it's done some new code, it's just got confused along the way or something, because now if I put one in here, it's still going to confuse. No? We've got an unidentified scene texture lookup, yeah. Oh, right. Yeah, I haven't seen that one before. So the correct approach without scene texture, now it's like, yeah, I mean, this is exactly what I was expecting, and we could have just done it with the regular bloody nodes. Because if we go in here and we just go custom depth mask UE5 and go to our images, someone will just show us like, yeah, there's an if here that does it through custom depth stencil. There's one here that's just an if. This is essentially what I was going to do, but I was like, you know what, I'm gonna be cool and I'm gonna use ChatGPT to see if it can do it for us, but then it just decided to go crazy. So now it's just telling me to just do regular nodes. So now it's just saying if custom depth, and we'll take the mask as suggested by chat, is more than 0 and custom depth is less than pixel depth as tolerance return else 0. Oh no, it did give us this. Pixel depth, custom depth, tolerance. Okay, well, let's see if this works. It should just be a mask, because it is saying here it's just a ternary operator that is just returning 1 or 0. So for anyone wondering, this question mark means ternary. Okay, we have our game already open. So yeah, now we have our mask. So we can use that to... Well, we don't need to do that. We just put our circle mask in like this. This mask is actually the wrong way around. So we noticed it was white on the character. We want it to be white elsewhere. Okay. So that should have been a lot easier. It took 10 minutes. So we've got our character mask. I'm wondering how many artifacts we're going to get now. Didn't work anyway. Did I multiply it? Did multiply it. Oh, sorry. I had it. Maybe I did have it the right way around. Okay. Let's keep these both open. Go to our material. Oh right, okay. I'm being a fool. This isn't a stencil mask either. This is a depth mask. Depth mask. Is Unreal about to crash? Yeah, okay, so I was right. It did need to be -1. Okay, so this sorts out the issue that we had here, and then someone in chat asked, do the city next. So next thing we're going to do is the city. So yeah. Okay, well thanks chat for working through that with me. And so now we have start of our effect. So we can run around. We've got something pretty cool going on. Okay, so next up is the city. Let's actually just use these meshes. And can I replace... I actually just want to get rid of all of the corner stuff. We're just going to use cubes for this demonstration. So let's make a little city. So what we'll do is we'll use PCG. So we just tag everything in here that we want to render to PCG. And we tag it with something like city, let's just say, or I don't know, world meshes or something. What would we call this? We would call this, we'll just call it Holomap world. That'll be a cool tag. And then I'll folder all this up into this new folder here. Oh, come on. Let me do that. Cannot change the SM RAM3 folder root. Not allowed. Okay, then I'll cut it all and paste it. You're gonna let me do that? Nice. Okay, so this is world. The reason I wanted to folder this up is so that I could just grab it all now, and we'll just make a couple of example areas outside. Oh wow, there's an edge of a world there. Make sure we got some diagonal stuff. Okay, let's go make a PCG for the Holomap. So in the Holomap, we want to create PCG, which I do not have enabled. So let's go to plugins. We'll just type in PCG and we'll get the content generation framework. And yes, we want to start with this. Save all of that. So what we do is we get all actors with the tag of Holomap world, and that gives us the position and bounds data for each one of those cubes. So we just turn that into a mesh. And from there we can do some more shaders. We can do some, what have we got on the reference? We've got some sort of gradient vertical fade, and we've got some lines that we can see. So maybe we'll try use GPT to generate us those lines as well. So yeah, gradient vertical fade with some lines will be cool. Okay, so just for anyone who's joining in, we are in the wrong map. It's a cool thing here. Okay, so creating the PCG. PCG graph. Let's just go PCG underscore Holomap world. We bring this down and do get actor data, and we do all world actors by the tag Holomap world. Do A on here. We want to select multiple, and then just drop that into our world. We'll get a bunch of cubes around these assets. I wonder if we could actually get the primitive data of all world actors that are tagged and see if that better aligns. Multiple. So we're actually getting non-diagonal here, which is not ideal. Obviously that's wrong. We want single point, so get single point. There we go. Okay, so we have this, and then we basically just turn this into a static mesh spawner that just spawns the exact same asset that we were using. So we got that. And the reason we're doing this is now it's going to create a HISM, like a nice optimized mesh that represents our C. And so these could be shops and stuff, but we're just going to represent them with cubes. So in the mesh entries here, we just plop in our static mesh. And so you can see we've got this, this asset now. And all we do from here is we grab that PCG component, PCG Holomap, and we go to our actual Holomap. And I believe we can put our PCG right in here. So let's do our Holomap. And for now, I do want to scale this down, but it is a asset. Maybe we can get mesh. Okay, so now I just need to figure out how to get the actual output from this. But let's see if is it PCG scale in Blueprint Graph. I'm just going to look at my other screen for this as well. We want to go here. This will adjust all the points. We don't really want to do that. We've actually added a PCG component too here. I wanted to have a PCG volume. Okay. So what I'll do is I'll put it into our world. Oops. Put the PCG into our world. I'll tag it as an actor, and we'll just call this PCG world. And then in here, just get all actors of with tag. Actor class tag. So we'll just do this. Begin play. We'll do PCG volume. These are hashed, so it's quite a quick command. So we'll just get the first one and promote this to a variable. PCG world. It's Wayne's World. Let's keep our graph clean by using these as functions. So init PCG map, or PCG world, what you call it. And then set scale. Is there a root component? Yeah, cool. So set scale. I guess. What message? One sec. We want, okay, anyway, so is there any chat going on right now? No, there's not. So I hope everyone's still enjoying this. We're going to turn what's flickering here into our map, and then we're going to shade it. So we've got our actor when we're knitting this. Let's attach it to ourself. Attach an actor to, let's just say our, let's make a new, well, let's just attach it to ourselves and make a new scene route to house things, because then you can move them and stuff. But well, actually, yeah, we're gonna have the city and any sort of world elements on something, because as we move, we're going to need to translate the world. So let's actually make a route for that scene world route. So we'll actually add it to this. We'll keep relative, I think. Probably makes sense. Maybe. We want it to be wherever it is shrinked, and then I'm gonna run through it. Keep world. Let's just keep world, and then figuring out this scale here. Let me open an old project, because I've done this translation before. It's like an inverse scale thing. Waiting for it to open. So once we have figured out relative scaling, so we think about it, it's huge. We're shrinking it down to our map. I suppose it doesn't matter. We can do whatever scale we really want. Let's just put a scale variable in. We'll call it map scale. we'll just do a float, which will multiply. Well, actually, we'll just plug it in. That's fine. So it's just like 0.2 scale, let's say. It's attached to us. This this mesh will not have an obvious origin at like 0, right? Like we're just not going to see. I don't think we're going to be able to get that info unless I'm able to tell. If I set this to 0, that might work. And then presumably it's going to generate once on begin play, and then I'm going to attach it to my character. So let's just make sure that we put a delay in here so that it gets a chance to generate. Actually, no, I don't need that silly delay. We hate silly delays. Because I think what you can do with PCG is tell it when it generates. So if I click on this guy, it has a PCG component here. It generates on load. And so ideally that means it doesn't generate afterwards. And then we're going to attach it to ourselves and shrink it. Let's just see what that results in. So now, yeah, we have this world here, which we can actually walk over, which we will need to address. And it's also not really attached to us. It's not moving. It's not actually moving with us. It's attached, apparently, but it ain't moving. It's definitely scaled it, though. The fact that it's not moving, I find interesting. It might be the case that the meshes aren't set to movable. So let's have a look in our PCG. Click on this guy. I don't want to snap it to the target, because if I snap it to the target, it's going to offset it. At least I don't want to do that right now until I know that that math is necessary. If I keep the world position, attach it to my player, and then scale it down from there, it's actually going to scale it from 0. So it will move it back towards origin. Let me just fix this first. Firstly, we have collisions. So we don't want collision on there. And next up, what we want to do is, well, we want to put a material on it later. We want to see if it was movable, right? Because I didn't see it being movable. It is movable. So it's attaching, it's keeping its world location upon attach, and then I'm moving around and it should move as well. But it is not moving with us. So that is a bit of a problem. At least now we're not walking into it, so as we walk around later, we're not going to worry about that too much. I wonder why it's not moving with us. There were some errors apparently in the log. Maybe this PCG is, there we go. See this here? There we go. So now it's doing that. That's cool. We obviously don't want to rotate it, but we do kind of want it to move with us. Or maybe I need to come up with a different type of math for this. Because I want to orient it such that my relative 0 to its relative 0, and then it moves around. So maybe I don't even attach it at all. Maybe that's a bad idea. But I do have a reference to it, and I do have a tick function that I need to write, because we need to move it with us as we're moving. So let's get a function going on here. Let's get a movement function going. and we'll just call this update PCG world. And it will do various things to update the PCG world. As long as we have a world, let's set the transform. At the moment, we're actually just going to set location. Set actor location. And we need to get, based on our map scale, our character's location, I guess multiplied by this. And we'll just try this for now. What we're saying in this function is, if we've got our world and 0 is in the corner, and we've scaled it down by 0.2%, and my character is at a certain location. Well, actually, no, this isn't going to be right. Let me relative location that's going to be Absolutely, yeah, you're on point there. That is exactly what we're going to be working towards. So we can either use a, well, we need to figure out the exact logic before we just start coding things, because we can translate and transform and we can mess around with it for 20 minutes, but I'd rather just know exactly what the problem I'm trying to solve is and the exact nodes that we'll use, because there is a translation involved and it's based on the character's position in the world. I do want this map. It's going to be moving. Once it's scaled down to 0.2, I do need to move it first to my character and then relative to my movement afterwards. And because they're both based on 0, the relative is literally just my actor's location multiplied by a value, because I'll be at 500 units, but on that little map, that relates to something else, right? Well, 500 multiplied by 0.2 in this case, as to where my character should be. I could just inverse the location here into local space of the PCG component. We didn't actually edit the actor itself, we used this. That gives us a local, that gets us my position locally to the PCG. Like, it gives us a relative location basically to the PCG world, which is the same as this, because this is 0.2. This is the same thing. Character world position multiplied by scale. If my character is negative 100 in the world and I multiply that by 0.2, it will become closer to origin. If I'm 100 up and to the right of the world and I multiply by 0.2, I'll get closer to the origin. So in all circumstances, all PCG that's generated in a relation to the world from 0, it's all going to be relative. Yeah, it doesn't matter if I go down to the left or up to the right. Another thing is we obviously don't care about Z value. I'm interested where it puts. Oh, my engine's crashing right now. So either it doesn't exist or crazy's going on. What I'm going to do is move these away from 0 so I can actually see the origin of the world. I don't really understand what that means. Would it be relative location of PCG on character? Yeah, need some more context because I'm not understanding what you mean. Think about this on the FigJam board as we grind through this awful translation logic. So I'll take a picture of our world to get us started. We've got this world. And we're going to shrink it down like, well, based off of our origin here. Hopefully. As long as that is actually correct. And then we've got our little character. We want it to be I guess firstly what we can do is we can literally move the PCG world to my character's location. And then we'll do the maths afterwards. Because then we just, yeah, so now we have this world. Now we want to translate this based off of my position in the world. What plug by 0.2? Possibly negate this. All right, there we go. So now we've got something working for us. You can see we're actually moving around a tiny version of the exact same world. And so the way that we did that was no translation, none of this. We just, because we know we're all based off of 0. We're taking the actor's location and we're saying, move the PCG map to my actor's location. And then from there, we're adding the offset, which is the map scale of where I am actually in the world. So it shifts it. I did what you said. Oh, that's wonderful. I didn't see you mention the negate vector, but if you did, that's my fault. And now I will hand over the baton of success to you. Yeah, I didn't understand what you meant. That was my problem. I think it was just like too short form. Obviously, if we were having a conversation in person, I would have understood maybe what you meant because you'd be able to talk. Cool. Okay, Cluedo's got us in for the win here. So this wasn't something that I figured out. Although I do actually have my project right next to me where I actually looked at the code, and so you can see in here. we actually have a working version of this map that we're actually recreating. So let's go on to the compass next. Now that we've got our world, actually let's shade it. Let's make sure that we're going to shade our world as well. So we have this cool thing. It's not small enough. Let's actually make it a little bit smaller. I think that would be a good call. And then we'll shade it vertically. I think it needs to be probably even smaller, possibly. Let's get a shader on here. Okay, so m underscores, we'll just call this, I guess, Holomap city. And from here we'll use, I think it's called like a bounding box based UV. And we'll use the Z value to lerp, linear interpolate. I guess what we could do as well is actually just cheap contrast and multiply this. So we'll say strength, we'll just say 1, we'll say contrast here. No contrast to begin with. We'll lerp this say top color and bottom color. So we've got that. Next up, we are going to change this at least to a translucent material. It will be unlit, and we will mask out. I think we can just plug this into emissive, but then we're going to mask out the alpha channel, hopefully. We'd actually have to combine these in order to do that, so let's just make another lerp. Plug this into opacity here, and then change our top color to white and our bottom color to some sort of gray. So we can see this is inverted. We'll just call this what have I just done? Let's make sure here. Okay, so well, basically just broken the header. Oh, god damn it. I did the same thing again. Okay, so top I am going to have white, and it is going to be 80% opaque, and bottom I'm going to have as slightly grayer and just like 20% opaque. So we'll just plug these in, but even less the opacity here. We get a cube. It's kind of doing what we want. So let's create a material instance for this and plug this onto our, I think we plug this into our PCG. We could also just do it. We can't redo it here. So let's open up our PCG. And we'll plug this material into here. Where is it? We got the instance, plug it in here. Play. I think it's probably compiling because it's going to need to use the flag mesh component flag. I thought it would be compiling. Doesn't seem to have actually applied. Let's have another look. Did I apply it as an overlay material by accident? I may very well have done that. I do that all the time. Yeah, I applied it as an overlay. That's an accident. So let's just plug it in here. Interesting. It just disappears when I move. It's new. Wasn't doing that before. Resaving the shader. Something's messed up. No idea. No, yeah. Unreal just says no, apparently. So if I show this, what's going on with my PCG right now? Save everything. Open the PCG. No overlay material, but I do have a Holomap material. Let's double check that this is used with static instances, so that's correct. That's what we want. We're using the bounding box. Actually, it's the bounding box. That means that might not be good. Yeah, we might. It's not the bounding box of every individual element. It's the bounding box of the it's the bounding box of like the whole HISM. So you're getting like this not great representation. Do you know if it's safe if I drag and drop an asset into a folder from project A to project B? Yes, you do need to just keep the same folder structure. We've done it a few times on these streams. So if you don't want to manually do this, you just pick the asset or assets that you want and you right click and you can find asset actions migrate here. And so if I was to migrate my Holomap right now to another project, it's actually going to tell me all the things it's going to move. And then I just press OK. I go to another project. Let's just use PSX. And then you find the content folder for this. And then you just select that folder. And what it's going to do is it's going to move all those assets that we saw. So asset actions migrate. It's going to move all of these assets in the folders that they are relevant to another project. Do I have a project library? I have a lot of projects. I probably have about 10 active projects right now, and then like that are like on my computer, and then I've probably got like 50 that I literally this weekend have moved to my deep storage because I'm going to be reformatting my PC soon and installing epic components. I just spent some money on some new components for my PC. So I've got a new CPU coming. I've got a 64 gig of RAM coming, and I've got what else have I got coming? 3 fans, because my fans have started like after 7 years since I built this rig. My fans have started sort of wearing. Okay, anyway, so back to the actual work thing. Yeah, we've got this issue where this is not instance based. To store all in one place and pick from there. I do have projects that I call like Bank 5.4, Bank 5.3, Bank 5.2, because some assets just never get updated on that marketplace. And then from those banks, I will sometimes pull things from the bank that I have on a hard drive, and then my projects are on my SSDs. Yeah. So here's a good place where we can see a bit of the issue that we were having. But here's a really good place where we can see the issue. So let's open this up. Let's open this up. Okay, so it's actually not too bad. I like this. I'm okay with this. This is kind of what I was looking for. And the next thing that I want to do in this material is we'll go back to GPT again. Let's have a look. HLSL grid here. I want to just create a custom node HLSL for UE5 material graph that allows me to configure a weld distance, yeah, for separated vertical lines on I want it in world space. I want the lines to be rendered in local space, so that when I move up the ledges, sorry, it doesn't know about what I'm actually doing. I'm just going to say this and see if it gets it. It's based in world units, so that was probably a bad idea, but we'll see. I just like doing it in world units for some reason. So I'm going to ignore everything else that it says while I go do this. Let's move this over to our bounding box Z gradient. We'll actually name these. So named reroute is just gradient color. Named reroute for this is gradient alpha. And what we're going to do next is apply this, which is going to be our vertical lines. So if we quickly just go back and look at our reference piece, we have these lines that we can see just moving up our asset. So I want to get that in. So that should be here, hopefully. GPT doing work today. Named reroutes. So we're going to say vertical lines. Okay, we have probably mention to GPT. So I'm reading this here. Local position is world position minus actor position, or use the object position node. We can probably get away with using the instance world position for this, and we'll see how that goes. But we have local position, we have the line spacing, have the line thickness, and we have a contrast that's given to us, even though I didn't ask for that contrast. Okay, and these are so line spacing, we got line thickness, we got contrast. Awesome. Did it give us some example inputs here? What did it say afterwards? 100 in the line spacing is for 1 meter, so we want this to be like 5. So it's like every 10 centimeters, every 5 centimeters. The width 2 would be 2 centimeters. Let's go with that. Actually, this might be. Wait, what? We'll see how this goes. Gradient softness, higher, sharper. So let's just go 100. Line thickness, line spacing, and then local position. So instance local position. Sweet. So that's what we wanted there. And now that we've got these lines, we just need to decide what we're going to do with them. We're going to add them directly, both of these for now. Let's just see, and then we can decide what we might want to do with it afterwards. So we have an absolute nutty amount of lines. Let's just say 1. Let's say here 5, 10, 50. Okay. Then if this was 10, oh yeah, 1,000. Cool. I mean, this is interesting. It's yeah. Anyway, it's not exactly doing what I wanted. Let's take this into, or take a look at this in our world, and I'm pretty sure off the bat we've got some issues. Yeah. Just move this over. Okay, so line spacing. Yeah, you can see obviously that this isn't set up. We can probably figure out why just by reading the code. So if we look here, we've got an X mod, we want a Z mod. And so let's just take a look at that. Where is our game gone? Here. So I actually wanted to add it to our original gradient, but we seem to have lost our original gradient. Did I multiply? I added the vertical lines to the alpha. So if we have this nice representation. But then I can't even see the gradient anymore, so it's not. Maybe my vertical lines logic isn't clamped, and it's actually taking away, like when I add this, it's actually adding -1 to a lot of the space. So I'm just going to add a clamp in, like just whacking a clamp in here. On the right, on the correct side of the asset, or the node. So yeah, I was right. It was doing that. So what I'm seeing here is obviously we've got these really solid planes at the top and bottom, and so I'll mention that to GPT and see what it says. I've adjusted to Z. Firstly, I've adjusted it to, what did we call it? Z mod. I'm seeing pure white planes at the top and bottom. The mesh. And would compare it to just the lines on the outside. ChatGPT is going to make me a lot dumber or feel a lot less smart as time goes on, because why is it now asking me to add local normals? I need to go and well, I see why, because it needs it. It needs it for the logic. Okay, cool. Okay, so world normal. No, world normal. No, normal. Give me the normal. Varix normal. That'll do. We've got a local normal here. Let's add that to our variables. Plug it in. Got line thickness, contrast, line spacing, local position. Yeah, cool. Okay. Now I need to tell it again. I mean, we are getting close to the visual from our reference. We just need to contrast a little bit more. I need to move some of my nodes around to get this to contrast nicely. Let's tell GPT about this error here. Modifies Mr. Paperboard type error in the custom typically means that you're trying to declare a variable with a type floats something equals in a way that violates how it parses the code. So what's the difference here? What did you do wrong? Float zmod is an abstract fraction of the z divided by spacing. Yeah. Float line is 1. Which is oh, okay, I see. No, float line this is the new code, this is the old code. Float line equals 1 minus saturate. Float line equals 1 minus saturate. Z mod, yeah. Line equals pow. Line contrast, cool. Side fade is equal to 1 minus the abstract local normal Z. Same as it was before. Oh, and then line more, and then it's saying, then it's just doing an operation on line, but line doesn't yet exist. Or, no, line does exist, it's all the way up here. So it's doing, so yeah, this is where the major change is by the looks. It returns line. It does float. Side fade is 1 minus, which is what we have here. But it wasn't allowed to do this. Well, we'll see. I'm not convinced that this is going to suddenly do something. Okay. How long have I been using Unreal? Hey Nils, I've been using Unreal since 2012. We're 2025 now, so 13 years. I started at university in the UK. I would chalk up a lot of my just like broader knowledge of the engine to game jams, and then working on teams as a technical designer. So part game design, part code, part art, and helping different people in different teams and sort of being exposed to a lot of different disciplines. And now that GPT's around, obviously, and the engine just has so many tools, it gets to that point where as a solo developer you can do a lot of things. Right now though, I am just focusing on mastering UMG. and technical art for the purposes of UMG. And especially with the advent of AI, I'm also interested in how I can leverage that for code in particular, for integration like we're doing right now. So let's plug our new lines of code in here, and now it just says local position Z is local normal Z. I'm just going to tell ChatGPT to take a hike. Don't make me extract dot Z. Do it in HLS. Yeah, I don't want to have a busy graph. I just want to plug the things in. Thank you. Yeah, it changed the variables on me for no apparent reason. Okay, so float line equals 1 minus saturate. The modifiers must appear before the type. The modifier. What's the modifier? I'm going to tell it one more time here. Error modifiers must appear before type at float line equals 1.0 minus saturate, etc. Also, unqualified ID at line equals power. Also, did I do something completely messed up here? Local normal. Yep. Local position, yeah. Line spacing, yeah. Line thickness, yeah. Yeah, it's done something mad here. Oh yeah, it's always going to be an underscore thing. But I think in this case it's actually syntax. Yeah, people keep saying it's really blurry, so yes, I can't really help too much with that because I don't know what the reason is. I have good internet and I have my OBS set up in the way that was recommended. If you're on Twitch, actually, Twitch might have an issue. I might need to up the bitrate for Twitch. Actually, what's the max bitrate for YouTube streaming? Okay. Let's have a look at this quickly. Let's fix the bitrate to 4000. Yeah, let me know if that improves it. It's 1920 by 1080. It's nothing major. ChatGPT, I was telling you off. I was telling you that you messed up. Also expected expression return line multiplied by side bit. I think it's not allowed to do that. Also implicit type is W conversion. Pixel material. Okay, let's see if it comes out with anything. If Twitch is only giving you the option of 720p, that'll be the problem, or a problem, because I am on a bigger screen than that, so it won't be 1-to-1, right? So does Twitch not have the option for 1080p? 720p on YouTube. I wish it was 1080p. Yeah, sorry, Alex. So here we're looking at blurs a lot of the text. I tell you what, I'll just zoom in more. The texts are blurry as fuck. Yeah, sorry. I don't know if increasing my bitrate actually improved it or made it worse. Let's I just googled it. I mean, I'm trying. The base canvas resolution in OBS must be set up correctly, obviously. I'll have to do it for the next stream, I think, because it's not letting me obviously change any of that right now. But I'm pretty sure I did set it up that way. Oh, it has to be at least 6,000 for... It has to be at least 6,000 kilobytes a second for 1080p. So I've just upped it. I don't know if that's going to update in real time for you guys. Let me know, and we will work through it. Okay, so I got some new logic. Bam. It now compiles. Awesome. So I just told it the errors. GPT went ahead and gave me an explanation. I'm going to bring this back over and then jump back into the level. So now we have our nice lines, but again, I've got an issue where I've lost the okay, so put this here. Got this Holomap. If I just plug in our gradient alpha, we've lost the gradient. So let's go back to this. We've got a material instance here. So let's just go. Wow, why is the contrast 1,000? That's crazy. Drop a 0. The default contrast is 1,000. That seems wrong. Go change that. Let's put it to 0. Okay. That's our default contrast. Strength. Go back to here. So what we've got here is a bunch of named reroute nodes that we've given our own names to so that we can clean up our graph. At the top here, we've got our bounding box gradient Z, which is this first effect. And now we've got our lines, which seem to be working and not cutting the top or bottom. So I should just be able to add this. And so now we get our cool lines in our graph here as well. It's a bit anti-aliased in certain places. So what I might want to do is actually add this to the emissive instead. So it's not fully opaque lines at the bottom. Okay, something weird there. I have saturated it actually. Yeah. So I've already sorted that out. Why would that happen? Oh, I see why. Because my opacity is just 1. Yeah, what I want to do is multiply our lines here. I'm not going to change the color. I don't think the colors is super important, but we'll leave it. We'll take the vertical lines up here. This will be our color. I'm going to say line color. Whoops. We should really lerp between using what we'll do. This will just give us more control. We'll lerp using our vertical lines, which means that our white lines can be one color and the rest of our gradient can be another color. Not that I expect to do anything with this because I'm going to leave it white. But it does show some cool stuff. So line color, and then fill color, we'll call it. And then we'll plug this into base color, and we've got our gradient color as well, which means we'll actually multiply here. This just goes into here. Like that, yeah, we've got some black going on now because we didn't color it. So for our line color, let's just use something obvious like orange. And then we'll use white for our fill. Swap these over. I always thought it's 0 to 1. It's always 1, 0. It always gets me. Okay, so now we're just very barely able to see that we actually have like these orange lines, which just gives us the control. Which I am just going to set to white. Because I just want them to be white. Cool. So that'll be our effect. I'm going to leave it there. And then we can sort of run around our city, which is cool. Next up, if we go and look at our references again. It's actually got like a blue tint to it. So I kind of want to take a look at that. Makes it feel a little bit more like glass. Oh, we had that bottom color, top color. I've just messed something up. I was already coloring with the gradient here. So here we actually just put this directly in. Yeah, the pin tooltip, it just says lerp. It just says lerp. And I'm like, is A 1 or 0? Control, oh my god. Everybody on stream, give Cluedos some karma. Or whatever we're going to call it on Twitch in this case. The linear interpolate, blah, 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 blah. If the alpha is 0, the first input is used. If the alpha is 1, the second. Okay, cool. Okay, what can I do that on? What can I do that on? More, I could do it on everything. What about you? HLSO, yeah, we knew this already. What about this one? It's an external material. Never mind. Okay, so that's awesome. Top color. We said we were going to go bluish, so let's go bluish. It's not working. 50. Can I have blue, please? Yeah, it's really not. Doing what I want, which is a shame. Yeah. Something that I would go in and play with is how the how this contrast and multiplies. In fact, I might just try it now. Let's just multiply first and contrast after. The idea is I want to make that 0 and 1. I think multiplying the 0 to 1 and contrasting it are probably the same thing, but this was supposed to replace a power node. So if this isn't replacing a power node, then it's kind of pointless. And also, I think here what I should probably do is just clamp it before we go into our lerp, because that's probably why changing the top color is affecting the bottom color right now. So I should be able to say I want red at the top. Yeah, that still doesn't work. Interesting. Also, we've got all these variables. We should really think about naming them. Got a lot of nasty aliasing going on with this effect. Wonder if I can tell GPT about that. What we got here? No, that's not the right one. Let's go. Is it this one? No, it's not this one. It is this one. Okay. So I'm getting a lot of aliasing when the lines get close together. Yeah, luckily we're not in the post process. I'm getting but it is that same kind of thing where you're like, is it TAA? Is it TSR? Which is anti-aliasing method in the project settings for anyone wondering. I'm getting a lot of aliasing when the lines get close together. Any fixes? Maybe it will do something in HLSL that'll like mask it out, which would be cool. Add screen space anti-aliasing based on derivatives. Anti-aliased procedural lines using F-width. Heck yeah. F-width adapts line smoothing based on pixel density and viewing angle. Smooth step creates the soft transition instead of the hard step. If you see aliasing, increase the effective F-width basically. Want a glow-like effect instead of a sharp line? Use this. Final result. Yeah, scales well when zooming in and out. Let's see if it doesn't just change all the variable names on me again for like the 4th time. So it is resolving something. Let's get this line. 1, 2, 5.1. No, okay. It's actually just clamping what I'm allowed to do. It's actually just stopping me from doing it. Line color. So we need to control at least the opacity of the lines. It's also just stopped me from really doing what I wanted. So I'm just going to go back a node. Come on, Control Z. Don't crash on me now. Why is this not updating? Okay, it's not updating. So lesson learned. I need to Control Z doesn't work when you Control Z through a yeah, it doesn't work in the customers HLSL code. Okay, so let's bring this back down to a nicer value. Okay, so that's it. I'm just going to move on now because I'm getting bored of looking at the city thing on its own. So let's go and actually look at, well, first off, let's go and look at the actual compass part. Bring Unreal back over here. I want to, where's Unreal? There it is. In the project settings, I actually want to look at anti-aliasing method here. We're using TSR. Let's try a different one. Need it to stop playing in a separate window, and we just want to play in the viewport here. Oh, do you see that ghosting? Horrible. Yeah, I mean, yeah, the better 2 options, I suppose. Really nasty though. Really what we have to live with? MSA. What is that one going to do? Well, it's no longer jittering, but that's because the entire screen is no longer aliased at all, and so everything is jagged all the time. So yeah, if we turn it off, yeah. Yeah, I agree. Understanding it would solve a lot of my problems right now. Okay, we're just going to stick with what we had before, which was this. Let's do the compass part. So we're going to create a widget, and let's actually look at our reference again. So we've got this lettering. We can have additional elements in here, which is why we're going to use a widget, and we're going to wrap this widget 360 degrees around our character, and we're going to face it, I guess, north being, well, whichever way north is. Yeah, which is that way in this case. So N should face this way. So let's make a quick widget for that. Widget underscore Holomap. And let's go custom size. We'll just bring it out here. Let's start with an overlay. So we can see what we're doing. There's two ways that I do this sometimes. I will either use a texture, and I'll just have it wrap the texture through a material, or I'll construct the elements in the UMG so that you can edit it that way. It's really up to this conversation with your artist, really. What I'm going to do is I'm going to use a texture. I think I'm going to use a texture. I have a texture prepped to save a little bit of time. So let's have a look. Where did I put it? I lost the texture. What time are we at on the stream here? Double checking. We're at 2 hours 10. We got half an hour left. I'm going to instead just going to create a vertical box and call this card. Open this out, make this a variable, and in our construction script we're going to have just like draw compass, we'll call it, and then for loop through 4 elements and create a widget. Let's actually make a new folder for this compass. There's going to be a few assets for this one. So we'll create a new user widget. Be our widget cardinal. This is just a text element. Just this N. Instruction set text. Default will be N, and then we'll just promote this to a variable. Text, and we'll just use that as the construction. So we'll create 4 of those. We'll add those to our cardinals. Add child. Oops, add child. Vertical box. And if we set it to fill, set horizontal alignment to fill, it will just fill that whole space. And so we can go and take a look at that. should, wait a sec, I didn't refresh this node here. I didn't set this to be exposed. So this exposed on spawn means that when you spawn a widget, you actually get a layer. Or you get the variable. So north, east, south, west. Got that. This needs to be fully aligned for now. We need to call that function on our compass. Draw compass on pre-construct. Another thing that we'll need to do is actually clear the children out of here. Otherwise, it will just keep creating them. So pre-construct is useful as a function. It's one of the functions in the event graph here. You can actually choose whether it's on design time as well. But now we've got this. This is not a horizontal box, so we'll replace this with horizontal. So we've got that filling. And then of course this breaks because I changed it. Child to it's no longer a vertical box, it's a horizontal box. Add child to a horizontal box. So this is the content here. And then we can set horizontal alignment. Still didn't like it. Oh, it's because this, yeah, of course. Alrighty. So that's not filling at all. But why isn't that filling? Set auto set size to fill. And set the horizontal alignment of it actually to the left. Now we have northeast, south, west. The next thing that we want to set up is a bunch of, let's just check our reference images. So we have all these little markers that we also want to fill in. And these are essentially, you know, at 0 to 360 degrees. So let's go make user widget underscore bearing. This would be a vertical box. We'll have an image in here. Do this in desired. So this is just, well, 360 divided by the number of, got a message here. Okay. Yeah, what bearings are we going to do? Let's do one every 15, so it'll be 360 divided by 15 units, and just say it's too tall. Let's actually wrap this with a size box for this case. Width 360 divided by 15. So it should be good. Just got to check. Get some text in. Oops. Text in here. It's going to be pretty small. And in fact, you might not even be able to read this when it goes actually onto our 360 widget. We'll see. It's getting even smaller. Let's go back to 1 times size here. We don't really need this because we're going to fill it in a massive circle. Let's just set this text to something like 45. This should be centered. Let's go custom with this. I'm going to center, yeah, so let's go with that. that goes into our compass in another box. So we'll call this one bearings. Cool thing about this method is that you get to promote all of these to variables at some point and have a compass that essentially can be any style from construction. Same if you do it with a texture. If you do it with a texture, it's a little bit easier in some cases as well. Okay. So we essentially want a similar function, but we're going to do this 360 divided by 15 times, so 23 times. We're going to add and fill our bearing to our bearings window. I'm going to clear this, do a sequence in here. That's set up. Okay, next up we need to expose the text on this bearing. Refresh this node. Okay, so for this, it's just this number multiplied by 15. I'm gonna go straight in there. Minimum digits I'll do as 2, so it's like 0, 0, 1, 5, so on. Now we should have, a bunch of these. This I'm gonna actually replace with a vertical box. Okay. And so now we've got, with a little bit of padding and a little bit of fixing, we've got some alignment of northeast, southwest. So we now need to wrap that in a circle around this asset, and it also needs to be at the right scale, right? So first let's add a widget component. So it's a widget, this is going to be the compass. And what we can do is grab our compass somewhere in here. This, draw it desired size, maybe. Maybe it doesn't construct on begin play, which is a pain. Yeah, we want it in world. I want it to be a cylinder. We're going to have to use a different widget because it's just not drawing. So okay, so we have a widget. I actually have my reference over here that I'm going to use because this bit was a pain in the ass. So for draw size, apparently I just used 1500 by 500. We're probably not drawing it at desired scale, so we're drawing it all the way over there. Seems a bit strange. Whoops, broke something. Okay, for the curve, yeah, we've got like a 180 degree curve, but I do know one of the things that you have to do with this is set the just look at my Venn graph here. You have to actually set the cylinder arc yourself to 360 degrees. Let's put this in a function. Collapse to function init compass. So one of the things that we need to do in order to render our UMG on a complete circle is actually be capable of telling this widget component that we created to actually be a circle. But you can't just plug in 360 degrees into here because it's clamped, but you can do it by hand. So we do that by hand in our init compass here. And then apparently I have a relative location offset, which is based on the draw size. And so if I go and just take a look at this quickly, we've got, where's my compass? Oh, compass, cool. People, compass. There's something different going on here. Enabled, pivot, pivot is 0, 0. We're getting closer. And then in our init compass, apparently I've got this code here, which takes our compass and sets its relative location based on some draw size information. Ladies and gentlemen, we have crashed. Let's reopen the project and actually just finish this stream, because I am, we're this close. And then, like I said, if you're on YouTube, or if you're not on YouTube, go subscribe to YouTube, please, because it's better than Twitch for having a conversation, right? Because we can actually have persistent comments. So jump over there and subscribe. And when this VOD goes up, go add some comments on things that you'd like to see in the future, UI you'd like to see from games that we can just do on stream. Let's have a look. So where's my project gone? UI streams. There we go. Hopefully everything's saved and we didn't lose absolutely everything. So what we didn't get to with the demo, and we may do in episode 2, is I really want to draw this line, and the way that you do this is you get a path using the navigation system, and you can actually output, you can do a synchronous find, and you can actually output all those vectors, and then with those vectors you could either use a generic spline mesh blueprint construction script to draw the spline, or you could use PCG nowadays to create a spline and draw the spline, and then we could add some cool materials to that, so it's like a little wire sort of doing a thing. For this one, what we would do is we would have these, I mean, this is just me thinking out loud, but I'd have these as widgets on a screen space panel. So one widget that like goes on the main screen, and then an item widget, or whatever we want to call this, a marker widget, that can take an appearance and a scale. And we would draw all those to that one widget, rather than having like a bunch of widget components, because that would just be really expensive. And then we take world positions and we just relative them over when we want to project from world space to screen space. We actually use the world space local to the player. And then for these vertical or these world space like gradient planes, I'd actually do those as planes added to the 3D compass that we're building. And we could do that all in another stream. Let me just go check the stream chat quickly. So we're good. Everyone's quiet today. We're back in the editor. We've got episode 5 here. By the way, either tomorrow's stream or the stream after, that's going to happen like lightning fast, because I'm going to upgrade my PC for once. It's been 7 years since I upgraded my PC. Okay, yeah, there's a bunch of Z fighting going on here, which is just par for the course in terms of what that PCG is doing. We can just hide the PCG. Can I hide on startup? Is that a thing I can do? Visibility? Hide on startup. Okay, so where are we at? We were building our compass, Holomap compass. We were actually in the Holomap. We had a whole bunch of stuff that's gone now. So init compass, event graph. So init that compass. Let's plug that in. Let's go here. I'm just going to copy the code from my other project. Here's one I made earlier. This. So again, this is the 360 cylinder arc fix. That allows us to do 360, and then we've got some pi math here with the draw size to just put this widget in a position that makes sense for our character. Now I wonder, and the reason for that is that when we draw this compass, I believe it's like 1500 by 500. I don't know why. In another editor window I've got open right now as a reference, it's like why it's curved like this. Yeah, over here I'm not getting that. But anyway, let's just hit compile and play. So did we actually call the function? Yeah, we did, but we didn't set the size. So like that. This compass needs to be 0, 0, geometry mode cylinder. What else? That should be it. Advanced. Apply gamma. I'm not doing that. So we've got a teeny circle that is moving incorrectly. So just in case it's changed in 5.6, let's take off this relative. Let's make sure that we are going in a circle. So it's just slightly behind us, but it's not the right size. I think we went with 5 meters for this. I'm wondering if it needs to be 5,000. Actually not changing the size, is it? Another thing that I'm going to do while we're here is I'm going to make a new material for this. Find parent for that, find parent for that. I'm going to copy this over to our compass folder, I guess. And so we'll just have this as M widget compass. I want to change some properties of this. We could have just done a material instance of the original, but this just allows me to do it a little bit easier. We're going to two-side it. We're not going to depth test it because our grid is non-depth tested, so this should probably be non-depth tested, as well as our buildings in the future should probably not be depth tested. Let's just, so that presumes that this is now translucent. Yeah, cool. So let's plug that material in here. There we go. Now we can see this guy. So yeah, I think we want, it's not letting me go to 5,000. Let's just go scale of 2 and scale of 4. Okay, so now we're at a size that we kind of want. Cool. Apparently it's the hottest day in Canada so far, Vancouver here. And I don't have a fan, so that's why we're going to end the stream soon, and then I'm going to start building my PC. Is everyone following along so far with the random mumbling and just stumbling around? I know what I want to do, and I know I've done it before. I'm just trying to illustrate to other people how it can be done. Obviously, it took me a lot longer to figure it out the first time. Usually on these streams, by the way, we do this from scratch. This is one of those rare cases where it's like, here's something you've built in the past, maybe you should show people what that is. So, yeah, that doesn't work. It's too big, I guess. 2,500 is probably the maximum that we can draw it. So we've got that. That's cool. I think what happens is, well, I just need to offset it back by half of itself and up by a whole of itself. And I'm pretty sure that's what this is trying to do, but we'll see. So it's not upsetting it, it's not offsetting it upwards. So what we'll do is we'll manually offset this upwards We'll just find out how much it needs. Oops. And that's not going to work because we're actually setting it here. We're rotating a vector, doing all this stuff. Cool. Okay, so I'm just going to actually add plus. There we go. And we'll just add 50 to this end result. We're going to go in and mess with all the scales in a second as well, because obviously all the numbers are annoying. So yeah, 50 ain't it. 50 ain't it. I'm going to say 250 because we've scaled this to 500. So yeah, cool. So that's looking good. It's huge though. It's also clipping a bunch. So what we can do for that is we can go and look at the bounds. The bound scales here, use attach parent bounds, which makes it immediately disappear. So let's just change the bound scale for the whole thing. So now we're not getting that disappear when we look around. Scale is off. Let's bring this back down to 2 units. Looks like the right scale, possibly. Might be wrong, but it's also incorrectly moved. I don't know what this pi was doing, but what we want to do is just get the bounds, I think, get the component bounds of this, and then just break. So this is half size. So we would essentially just set the relative to, well, let's try the relative as just this. Where'd it go? Oh man, it's all the way over there. What? That doesn't make any sense. Well, okay, sure. What? Maybe that's why I was doing this. I'm a little bit confused. I'm just going to offset it by its sphere size. Its sphere size must be enormous. I'm going to print these extents. What I'm expecting is an extent of like 500. But we're getting an extent of like many thousands. Wow, that's crazy. So what if we divide this? Is this something to do with just Unreal's way of doing something here? Oh, I mean, that just puts it back at 0. 1. 20. 3,000. Yeah, weird. I don't know. I would love to see how to set up a UI system in future videos, like one that would be used across all 2D UI that makes handling input focus more automatic, or a breakdown of the larger example project. Yeah, a friend of mine, well, his name escapes me for no fucking reason, also asked for a similar thing. I would, on that topic, like to open up Common UI and just build a sort of screen management and modal pop-up quick system. Like, here's just a setup that you could do, and it is largely based on just being a more coherent version of the version that was live streamed once by Epic, with a couple of fixes that I did to blueprint interfaces and things. And it also is something that I have built for what I call my foundations, right? So when I'm building out game projects, I kind of want like a foundation of a lot of things. Like this compass, for example, this is an asset that I've got that's like plug and play that I can pull into other projects that I've spent time like building, and then now it's locked away. And I've got the same for like game playability system stuff. I've got a whole bunch of stuff, marker systems, What I don't have is one for like that core UI from kind of like the boilerplate from start to finish, right? Where you've got like, how do you do your splash screens or your movie intros? How do you go into your first start page? How do you then go into, you got your settings menus and stuff, but how do you flick between those nicely and not worry about losing input at certain times? And Common UI is the way I would do that, because that's it's got a lot of that automated in there through the activatable window. And that is definitely an episode that we could do. I would love to whip up like a UI and just be like, just take any game. We're gonna look at 10 games and be like, can I make a menu system, a quick menu system? And usually these videos are a lot faster as well, but this one's quite involved, so usually I want these videos to be an hour long so I can get 3 of them, but sadly we're making something with a lot of moving parts today. So annoyingly, the component bounds just is a no-go there. So here we've moved it way too far forward. So I wonder if the scale here has something to do with it. Nope. So now we're good. I don't know what this number is relevant to the compass size, because if I set this to 3 now, it's like offset badly. But we're 2, so maybe it's the get scale. We'll try. I just want to know. I'm just curious. So if I get the scale like this and then multiply this by 2, plug that in here. That's good. So if I now say, actually this compass is 4. Nope, that wasn't. No idea. There's some particular math that I'm lucking out on because I'm using like generic numbers, and then we just need to move it up. Apparently less. Another thing that's a little annoying, actually this isn't, you can actually see, this isn't right. It's not actually aligned. There are some other annoying things that I'm not exactly happy with here either. Why is it rotating a vector as well? It's weird. I want to print this out, and then I want this to be like just 80 seconds, and play from here. Hit F8. It's saying 796, right? So if I go top down, it's getting hot. What's this size? 250. What's this size? 500. Okay. So the draw size, which should be 2500 at this point. Make 796, yeah. So why would we want to do that? What if we take the 2500 and divide it by the scale that we used, which in this case was 2. It's just 1250, right? Obviously I was smart at one point and was like, found the reason why this doesn't work, and then I used 3.14, which is pi. So okay, well, this is a pain. It's a big number. It's a much longer number than that. Yeah. So it's just really strange. This is obviously 500 because I chose to make a 500 unit thing, which means that this is 250. I guess then, yeah, because we've got a mesh that is 2,500 long, being wrapped around in a circle, 360 degrees. We know it's 2,500 units in this sense, and then we just want the radius, and we just want to move it. So let's just go back to school here quickly and just turn off everything and look at it and be like, yeah, it is exactly the radius. If I set this to 1 times scale, it's just underneath us, right? Interesting, looking at my sample, or like my compass route is 1 scale, my widget is 1 scale. I'm not, as far as I know, resizing either of them anywhere. So it's 1 scale. And it's 1,500 units, which is annoying. Because if you look at it, it's like a real nice size, right? It's like all the way around. Yeah, for some reason, mine, like, I've got the same, I think I have the same variable. Let me go find out. Reference viewer. Sandbox character. Where's my Holomap? Yeah, I can't change it from here, so. Widget? No. Compass. Sim. Compass size, 2,500. Yeah, I just don't. Like, why it would be off so much by so much. But we do know that we need to offset it currently by the radius. So I need to offset a circle with the circumference of 2,500 variable by its radius. Give math. P multiplied by pi multiplied by, which means that the radius is divided by 2 multiplied by pi, which is why originally this was 2 multiplied by pi, and then it was just the radius is the circumference. Maybe it's an order of operations on this node, so we'll just say do it like this. Do this math, then c divided by it. What? Has someone taught it that pi is 6.2? Maybe that is right. Maybe I'll just put pi in here. Get pi. I don't know why I'm rotating the vector by the relative rotation, but I guess it's important. In the event that you literally do rotate it. Gone. Disappeared. That's all the way over there. Why? In this case, I'm just going to plug it into the X and see if we're good. Which of course we're not, because we just established that that is not good. Well, I am struggling now. I'm actually like at the point of just being annoyed. What's D? Direction, yeah. 1. Which is why I'm not doing that math, I'm just plugging it in. Why is it 2 pi here? You're saying it's pi multiplied by 2? Am I crazy? I mean, it's closer at least. Give me the radius. It can't be right then. What's this? It's 1 times 2,500. What have I got my compass size in here? 2,500, yeah. And we get the draw size. What's the draw size right now? What's this? 2,500, yeah. And so I'll just tell it the maths. I have a widget of 2,500 units wide, bent in a circle 360 degrees, and it's offset by the radius when drawn. And just so that I'm not crazy, it's offset by that radius no matter what I put in here. If I put 5,000 in here, and I look down, I mean, it's clamped at some value. It can't go any higher. Begin play, and it compass set draw size. It can't, for some reason, go any higher. I find just like so weird. Let me just try 5,000. I'm wondering if this variable is not being changed in the parent. No, it's not doing it. So what if I say 500? Is this compass? Oh my god. Ah! I don't know if anyone saw that, but I've been fighting this code for like half an hour, and it was a tick box, which it always is in Unreal. For anyone that has used Unreal for a long enough time, you'll know. Sometimes it's just a tick box. It was the draw at desired size tick box. So now I'm convinced that this might just work fine. Well, I'm hopeful, I should say. Okay, well, I just lost all hope immediately within, like, the time it took to press play. So this one said 3.14. Been there. 3.142. Let's just hit that up. Okay, so pi in Unreal is whatever. Okay, so finally, we're at a point where we have offset it. We do need to do something with the y. So maybe 0.5 on the y. because it's like it's either buried in the ground or it's above us. Okay, so 2,500 is too big. Let's try 1,000. It's way too small. 2,000. We're gonna get the right number. 1,500. You know what? It's close enough. It's rotating with us, so what we do is we set this compass's rotation to world rotation. And it completely breaks the entire thing. Again, another thing I don't understand. So pi is both everything and the enemy. Good to know. Yeah, and also this tick box called draw at desired scale, which made it so that my set draw size wasn't working. And so for the longest time, I was just fighting to try and work through it. But that's the point. Don't just stop and give up, because eventually you'll check every possible point of entry and you'll find the bit that was wrong. And it's funny because earlier when I made the compass before we crashed, I literally looked and I said, and yeah, you got to draw this, you got to turn this variable off because otherwise this won't work at all. And then it crashed and I came back and forgot to recheck it. So it's just like my own fault. It's okay. We'll get it in the next one. So now we have our compass. We wanted it to draw with world rotation so that it doesn't do what it's doing right here. And I'm just going to go and check my project to be like, is this a problem I had to solve? Like another problem I had to solve? So it may very well have been a problem I also had to solve. So I'm going to add a scene component. It goes on this route here and it's just compass route. I'm going to stick the compass on it. Compass route is just at 0, I think. Yeah. And the widget is, for some reason, rotated by 7.5, but I think that's a value that's relevant to the n number. So we've actually offset this by 100, which won't matter because we're going to be changing the relative rotation here. This is relative. This is world. Let's give that a go. There we go. Right, so now we have a compass that moves. Let's go and fix our building material, because we've got an issue with the building material there. So we open up the Holo City material and we open up the Holo Grid map. We've already got ourselves a circle opacity. Well, this is the ring actually. This is the ring. This is the circle mask that we made earlier in this stream that will be on YouTube after. So go jump over to YouTube and subscribe there. Drop your recommendations or requests in the comments, or join my Discord. My Discord should be linked, and that's also a good place to catch up with me. Also, I'm going to do a shameless plug in like 5 minutes because I think it's really cool. We did a games jam last week, and it's going to Steam. So I'll show the video and we'll see what you guys think. In fact, if you haven't seen the video, go check it out, and then actually just tell me what you think. Once I spent an entire day debugging an array, came back the next day and realized I'd put the input nodes into the array in the wrong order, which is why I was getting the incorrect query. Yet you were looking at it and your brain was seeing that everything was fine. I've been there so many times where you're like, so I put the thing in the thing, and like logically it just makes complete sense. Why isn't it working? Like I've done everything that I should do. It's just not working. And then you're just like frustrated and you're just like glancing across the code. People do that with written code as well, of course, like C++, C#. I did it back when I was in a Unity-based job. I would just be there like, this makes no sense. And to which actually is a reason streaming isn't great for me, because I will, when I hit a problem like that, I'll actually go for a walk and then I'll come back that same day as part of my job, right? But right now I can't really just walk away from the stream. I can't just like go have 5 minutes, refresh my brain, come back and not be looking, like look at the screen with fresh eyes. So I feel like, you know, it's a little bit different streaming as well. But like you say, you walk away from the computer, you come back, you're like, oh yeah, that's not what I should be doing. That's not what I thought it was doing. Okay, so we came in here because we wanted the circle mask. So we're going to steal that. We're going to pop it into the city. So now we have our circle mask. We'll basically multiply our gradient alpha by the circle mask. So now everything outside the circle will be gone. Be gone, buildings. And you could do other stuff with this. You could do a gradient. You could make it sexy. You could do whatever you like. Okay, so it completely didn't work anyway. It's a circle mask based off of every individual element rather than off of the world position. So let's go look at that circle mask. It's because we're using UVs. So let's use... oh, this is going to be a pain in the butt. Get object position. World space. Let's get the distance between these two. And we'll do a 0 to 1 between, but by dividing this distance, basically, by a value. And we'll just say 500 units. We know, well, it should be 250. We know that 250 distance away is the edge of our circle. So if we have a 0 to 1 from here to here, and everything after 1 is bad, we could 1 minus this, and we'd get -1 to 0 is the good space. Basically, I want to use this as a multiplier directly into our mask. So right now, if I divide the part by the whole, it's like no distance from the object's position up until the point where we have it. I'm just going to jump back over to my music. Can't have no music. I just want to mask it. I don't want to use an if. Right, we're using an if. I don't want to spend too much time sitting here. So if this value is less than or equal to 0, it's 1. And if it's above, and if it's above, we'll do that. Could also just use a sphere mask. Oh, hello. Alright. Screw you. Oh, it's because the 0 of the object is right there. Would I need to just subtract 150 from this? Sorry, 250. Also currently masked. Ta-da! And that is how it looks. Perfect. Wait, let me just move over. Close your eyes. Okay, we nailed it. Didn't really work. This is cool though, moving through the sea. Okay, so the mask is hugely offset. And we use mesh particle pivot point. What if we just use a sphere mask? We'll use our new learned thing where we just press Control Alt. And in this instance, it does nothing. I guess it's a material function. No, it's not. It just doesn't have one. Okay, so A and B. It's A and B. Yeah, I'm making it. I was trying to use the distance to mask out beyond a certain point, but it's offset by. Yeah, I don't know what's going on there actually. Like, if I just plug my opacity in and press play, and then actually compile the material because we want to actually see the rest of it. We have all this stuff outside, right? And so if I grab the Holomap shader, we'll come down here to our circle that we were using. I was using the, but this is texture UVs, right? And so it doesn't work for this. Every single one of these has texture UVs because they're instanced cubes. So I want to use a world space distance from basically wherever my character is to wherever the world position of the pixel is. So I was like, okay, get the absolute world position of the pixel and then get the distance to the object position, which I thought would be, because it should be right here, right? But we're actually, it's not here. It's actually somewhere else. So, because we're shifting it around. So what we need is actually maybe a material parameter collection, possibly. It's the ism's origin exactly. And that's what I was getting at. Is like it's over there somewhere. It's like it's somewhere. It's not what I meant to use, which is the center point of this, which means I just need to actually put a vector into this material, for which we will use a material parameter collection when I can actually access. Or I could use the camera vector. I could do this without this. I can use the camera vector. Oh, camera position, sorry. No, I can't, because the camera position is not where the center is. It's like the camera position is over here, and it would fade out in the wrong way. I can't use the bounds because that's just not going to work. So yeah, I kind of have to plug. I have to plug a position in. So let's go make a material parameter collection, MPC underscore, let's call it game. And for this vector here, we'll just create a player position. So we'll save that. And in our Holomap, I think we have a tick, update PCG world. So we'll put it in here. Just press stop, set vector param. This will be PCG because they've added that now. So we'll do this one, NPC game, player position, and then we'll just get actor location for this. Put that in there. Back in our Holomap grid, we don't need that. Back in our compass, we don't need that. Back in our Holomap city, we get a parameter, collection parameter, and it should be game, player position, and we'll get the distance to that. So now we'll see if that works out for us. Circle mask, plug circle mask in here. Okay, it doesn't like that. Why don't you like that? What's the distance? Oh, right, yeah. Cool. That is complaining because player position, although I want to use a 3 vector, it's drawing into the parameter collection. There's a color that comes with an A. So it comes with an alpha. Does hit play. Yep, so we've got that sorted now. That's pretty cool. We could do some more interesting blending from this. But that is cool. That's pretty much the whole gaff, I would say, for today. I am interested in doing an episode 2 of this. Apparently I can't grab the thing, so we're just not, there we go. No, there we go. So that's cool. Maybe we should turn two-sided off on widget material though. That looks a little bit nicer. Then we could zoom in and zoom out. Like on tick, if we change that map scale variable now, the actual size of that world will change, and we could even affect the size of the grid that we're drawing as well. And in fact, it's actually kind of confusing that we're drawing the grid not in world space with the structures. It's a bit strange that that grid underneath our feet is moving at a different speed. So like in our reference game, I wonder if I did it a little bit differently. Can't run with it open in the reference game. That's kind of annoying. Well, you can't run with it open in the reference game. So we've innovated today in a bad way. So this is world space. So all we need to do is change it to local space gridding, and then that wouldn't be a factor anymore. So we've got this grid here. Currently it's all world space. Let's just say duplicate this and just call this local. In here we would not need the world position. So I wonder if I can get GPT to with world position logic. Now I want this based on local. Thing is, it still needs to move based on your position. So like there would need to be some UV offsets. There'll be a decent amount of work actually. So I'm not going to bother doing it right now. Although it would be fun, and I am excited to do it. Let's not do it right now. Let's call this stream. Let's call it. Cool little thing. We're partway there. One crash, and therefore a couple of annoying moments when it comes to solving problems. But we're somewhere. We're somewhere with that. So I'm happy with the result. Happy enough. And like I say, we could use path nodes, asynchronous pathfinding for this. This we could use an overlay widget that's on the whole screen, and we feed it with some information. Or better yet, we would just draw a material, and we would define these through HLSL as well. This thing here would just be a 3D widget, just laid down, I think. So yeah, we could carry on with this in another episode, I think, if we wanted to. I really love this. It's just such a cool project to work on. If you were in a games company, like the way it outlines all the floors of the buildings, which of course we have like actually replicated in our version. They've got it where the opacity of the grid lines are fading away at the top and more visible at the bottom. They've also got like there's alert like distance gets shorter as the building gets higher, which is quite cool. They probably fixed the flickering as well, yeah. I don't know though, because I'm not playing it right now, so I can't say for sure. I mean, this looks quite noisy and grainy. Yeah, fixing the flickering. So let's jump back and just see what the chat's talking about here. So at these at these sort of angles, we're getting this flickering. If we're face on it, we actually still get flickering in the distance. And I wonder if I go full screen here, if that still happens. That does still happen at full screen. Sometimes it's to do with like just being not quite 1920. Yeah, it's rendering at 1920. So yeah, let's have a look at that quickly, because you're right, that is quite annoying and it's not really shippable. My line art on buildings, or my line art on meshes, has banding artifacts. Flickering. Using the F width thing again. AA works by shifting camera in 3D space a tiny amount every frame. It's when the outlines are almost disappearing they will flicker. You can actually debug the AA and tell him to allow show frame 1 or 2 or 3, and you will see on some of them there will be no, in this case, like graphic of that element, because it is just a line. We're not doing a post process here. This is all in the pixel shader. Let's pop open get rid of this grid local, don't need that. Close everything down. Forget lunch and build my PC. I'm excited to build a PC. Don't know if you were here for that, but I'm super excited. I also haven't had a coffee in a while. Okay, so open up this Holomap. Not the Holo, the Holo City. Take a look at the vertical lines here. This is my current code. Let's see what it does here. Thanks for sharing the code. It's clean and logical. Almost like an AI wrote it, maybe. Maybe he's just complimenting himself. He knows it wrote it. Like, he must know. I mean, it's just another pattern. Maybe he doesn't know where the pattern came from. Okay, so it gave me something. I'm not going to read too far into it. I'm just going to paste it back in. As long as it didn't change any of my variables, we'll see if this did anything. Yeah, so this is the one where I can no longer get nice thin lines. I do remember this. And then I also remember that I can't control Z, the custom thing. So I'm just going to put the instance on my other screen for a second and play with the line thickness. So I can increase the line thickness and just make it a solid line, and I can bring it all the way back down to like 0.00001, and it still won't let it go beyond a certain thickness. So I could come in and I could say, this has destroyed the thin lines. They are all clamped to a fat with a pH width. So what's it going to say about that? Okay, it's done something. Let's plug it in. Has it got any more variables? Can it read? Can it read? Read this. Yeah, it can read it, so that saves me a lot of time typing it out manually. So that's great. Okay, so maybe now that it can literally see the error. Nope. A mount, which it gave me maybe a recommendation. 0.25. Let's try that. And then we need to actually define that here. Add a custom thing, and then shove that in there. Put the thing in the what's it and do the doodaddy. Guarantees that 4 pixels are consistent. GPU works by computing 4 pixels each time, so DDX, for example, replace your value with the value that was obtained on the other pixel horizontally. Yeah, so like you were saying, when you're missing one, it's like, maybe we'll... Let's have a look at what it's doing. It's blurring it. If it was blurring it, I would have expected a loop in there. Do I need to compile this? It's already compiled. Oh. Oh. Not too bad. What I would mainly want to do right now is first do what this guy said, and I'll just play with the indices. Oh yeah, you can see you can. Okay, so how do I undo that? how do I turn that off now? I need to like not have only render one frame of the temporal. -1. It does look good, but the opacity of the lines I'm not happy with. So I'm wondering if I have the controls in place to control that. We've got a gradient alpha and we've got a circle mask. We've got some vertical lines. Let's go look at how that works. It's all this stuff here. So we're just lerping to the line color. And so one thing how do I... It's cool. It's good enough. And then I'd maybe, I don't know, what else would I do? Not a huge fan that it's two-sided, maybe. Maybe just turn that off for a second and see how it looks. That's kind of cool. Anyway, I'll leave it back on two-sided. Okay, so that is our episode now. I am going to call it now. So you can actually play with the AAA, the AA amount now. So if it's 0, if it's 0.1, it's got all this mad flickering. If it's 1, you get this look. 0.5, 0.7, 0.8, 9. So for the line spacing as well, we can play with that. Just like 15. That's quite neat. Yeah. Kind of cool. I'm going to save all that. Close it down. And yeah, I will be back tomorrow morning, 9 AM. I think. Just need to confirm my calendar for tomorrow because I think I might have a meeting. But I'll be on at some point, so 10 AM, whether it's 10 or maybe it'll be a little bit later. Tomorrow maybe it'll be 1 PM PST till like 3, 4 o'clock. I did mention that I want to show you the game jam. So we did a games jam. Let's take a quick look at that. Last week we did a games jam. We live streamed the development of it. And we came out the end with a production, you can say. A small game jam final production piece. So it was an homage to Severance, if anyone's ever seen Severance. And it was a good one. It was good fun. Little jam that we did. It took like 2 days. I think we did two days of streaming, and then that was the end result. It was good for a first jam. I think, in another one I'd do something maybe different. Nice lighting. I did it all myself. That tick box that you can press where it makes basic cubes look great. Yeah. I spent ages on that lighting pass. I spent ages moving every individual light. There are no lights in that scene, by the way. Everything is done through emissive static meshes. And just clever use. Okay. Yeah, that's my message. The food's ready. It's time for my lunch. Thanks for joining. Hit like, subscribe, whatever you have to do on your platform of choice, but do jump over to our YouTube and follow there because that is where our VODs will live. And yeah, like the video if you liked it. If you'd like to see more, leave some comments of recommendations. I really do like interacting with you guys while we're streaming and answering questions and stuff. So thanks for jumping in again. And it gives me the motivation to do another one. And so we'll next time jump into maybe Destiny. I think someone made a recommendation about another kind of interesting creative UI in a game, which I need to go and take a look at, actually. Bayonetta Origins and the Lost Demons UI. So we could look into that. So that sounds cool. Okay, yeah, thanks. See you for the next one. Bye-bye now.